Hey there, Margaret. It is a little windy out here, so I hope that my voice will come across as nice and clear. There, the wind is picking up right now, so nothing I can do about that. I do want to give a shout out to Miss Mormon's class. Hey, we met all of them on a classroom Zoom a couple weeks ago, and they're back for this today. And a buenos dias to our English language learners that are also joining us. So wonderful to see you. This is definitely the coldest day that we've done one of these on. When I left the Learning Center about a half an hour ago, it was 47 degrees Fahrenheit, and it's windy too. It's a chilly morning, but I have to say it is so beautiful out here. You can see this blue skies behind me. There's some nice white clouds, and when I've got the sunshine on me, it doesn't feel too bad. Plus, I was happy to see some little pink flowers greeting me when I came out here. So these are shiny Lionias, and they look kind of like blueberries because they're related to blueberries. In the winter, I don't expect to see much color out here on the nature trail at Archbold. So some pretty pink flowers here and there is a nice way to start the morning. Well, today it is, yeah, there's that wind. Today we've got an introduction to the scrub, but what I want to focus on is how do things survive? To me, really the wonder of life, the wonder of biology is that things live, that they can survive out in the wild and reproduce. So there's a few different species I want to take a look at today and talk about the just amazing adaptations that they have to survive out here. We do have a couple special guests today from our drone lab, our map making lab, and they're going to show you some videos of how they use drones to study the habitats out here. It's pretty cool. So before I start showing anything, I'd like you to just imagine that you've got a group of scientists and you want to start a biological field station somewhere. You want to take your group of scientists, you want to move somewhere in North America and study all the plants and animals and how it all works together. Where are you going to go? That's the challenge. That's the challenge. Okay, so I'll tell you what I would think that I would want to do if I was going to start from scratch new field station. One, I want to go to a subtropical place, a place that is not all the way to the equator, but it's also not in the north where it's snowing. It's kind of in the middle. And I'd like that because that means we would have species. We'd have both northern species and southern species meeting in that area. So give a lot of cool stuff to look at. And so that would give us somewhere in the south. I would want a place with something really cool going on, like lots of lightning strikes and fires, frequent fires going through the habitats, because that would be really interesting to study and to figure out how all the plants and animals can live with that. Well, if we want the most fire and lightning, you're going to go down to Florida. Okay, so we've narrowed it down to Florida. Now, I know that the other really interesting place for life is on islands. If you can go to an island, you can find rare species that are nowhere else because they've been stuck on islands for long times and they've adapted to life on the island. They've evolved into new species. Well, it just so happens to be that Florida, in the middle of Florida, where I am right now, used to be an island. So this is a spot that sometimes it's an island in its past when the oceans have been higher. And then other times it's not an island and it's connected to the land around it. So that gives you times where animals and plants could be moving into this area, and then other times where they're isolated. And don't you know, we end up with all kinds of rare plants and some rare animals in this area too, because of all of those things I just mentioned. It's a difficult place to live. It's sandy. There's fire. It's a drought half the year. Then it rains the other half of the year. It's an island. It's been an island part of the time. What I'm talking about is called the Lake Wales Ridge. And if you could go up in outer space and look down at the earth and look down at Florida, you would see a little white strip in the middle of the state. And that white sand is this old sand dune island. It's about 120 miles north-south, little skinny strip. And if I was going to pick where to put my field station, boop, I'd put it right here. And that is what Archbold Biological Station is. It's a field station in the perfect spot in Florida to study all kinds of cool stuff. So when you're thinking what is scrub, that's all part of it. I mentioned the fire, I mentioned the sand a little bit. Here, I'll show you that white sand at my feet. And if I turn around here, you can see it a little bit better. There we go. See all that white sand there? Sometimes when we show people photos of the scrub that have never been here, they think it's snow. It's so pure white like that. You don't see lots of crushed shells or things like that in it. It looks like snow. And today I know up in the Northeast, it is snowing up in New York. And it feels today like maybe it should be snowing because it's really cold out here. I'm going to walk over here a little bit because the first species I want to look for is called an antlion. It's an insect. And I'm going to get down on the ground for this one. So let's mount this right here. And what I want to show you, if I tip this up a little bit, maybe you'll see that on the ground in the sand, you can see there are little pits here and there. Here's one right here, little pit here, little pit right here. You might walk right, sorry about that. You might walk right past that and not notice it. Or maybe you think that these are just made by raindrops or something like that falling down here. But these are actually death pits. These are death pits made by an insect called an antlion. And it digs this pit and it waits for ants to walk over it and fall into the middle. And it grabs them by its pincers, pulls them underground, and sucks out their insides. Pretty cool. Now, on a normal day out here, on a hot day in the scrub, it's very easy to dig these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I see pits all around me. But on a cold day, I find them almost impossible to dig out. They dig down below and they're just not moving. They're not doing anything. And normally they're good housekeepers. Normally they clear, have a nice little pit. It's all cleared out. But I'm noticing things like that there's bits of leaf litter all over the place. They're not cleaning. They're not doing anything but trying to get away from the cold and burrowing down there. But we are going to give it a try. So I've got my 2 different scoopers here. Normally I just use a little wooden spoon and that's all that I need. But like I said, they might be deeper than normal. So let's see, I'm going to try this one right here. Get a little deeper there. And what I do is I just kind of sift through the sand and look for them. And I know that right now, too, they're going to be hard to find because they're not moving. So I might end up with one in my palm, and I don't even see it because it's just basically playing dead. It's just not doing much. Okay, I didn't get one there. I'm going to try one more of these, and then I've got a plan if that doesn't work. Let's try one more. Let's see here. I can see all those little grains of sand. This white sand here doesn't have rocks in it, doesn't have shells in it. This is actually used to be part of the Appalachian Mountains. And in southern Georgia, the mountains over there used to have pointy pointy peaks. But today, if you went there, they're rounded peaks because slowly weathering and erosion has worn them down, and that rock slowly turned into sand. Ooh, did I get it? Nope. Slowly turned it into sand, and then it washed down here to Florida. Okay, I thought this might happen. So I came out earlier, and after much digging around, was able to catch one. So I've got it here. Come on. Come on. There he is. Okay. Now, first, you're probably not going to see. I see him right here. I'm gonna turn on the macro lens, and you'll get to see what this looks like. There he is. Oh yeah. Oh, you see how he moves backwards? You get rid of some of that sand for you. Hold on a second. I'm just gonna get rid of some of that sand so you can see him again. All right, here we go. There he is. And they don't walk forward. They always walk backwards. And they walk backwards kind of in a circle to make their pit. So it doesn't take them long to start burying himself and hiding down there. And you can see, I was talking about that sand. Look at how they look like little bits of glass. Okay, I'm going to put him on this little white thing I've got here. And you can see him a little better again. Oh, he's flipped upside down. There he is. Oh, look at those pincers. Check those pincers out. Can you imagine if this was like, you know, as big as a dog or something? It would be terrifying. All right, I'm gonna let him go. I'm gonna switch back around here, and I want to show you. So you saw that's what it looks like as a larva, but that's only one part of its life cycle. So we've got a video we're gonna pull up, and you can see what this looks like when it goes through its whole life cycle.
A larval antlion will catch and consume dozens of ants before transforming into its winged adult form. Catching and feeding on an ant can take minutes to over an hour. Once feeding is over, the carcass is thrown up and out of the pit. Underground, the antlion sheds its skin as it grows, molting into a larger, more advanced larval stage. In its last larval stage, the antlion will encase itself in a cocoon made of silk and sand, where it becomes a pupa. After weeks in this cocoon, a winged adult will burrow its way out. When the adult emerges, it scrambles to climb up the nearest perch. From there, it inflates its wings and expands its body by circulating blood. Adult antlions live for a short time in comparison to the larvae, just long enough to fly off, find a mate, and reproduce. Though they look like dragonflies or damselflies, antlions belong to a completely different group of insects, one that's a little less skilled when it comes to flying around.
Oh, I love that video. It's hard to find those adults around, so it's nice to have a video like that. I've never found one that was in the pupal stage. I would love to find one of those, but you know what? You probably wouldn't notice it because it just looks like a little clump of sand. I said I wanted to talk about how do things survive out here. So let's talk about the antlion for a second. Now, for one thing, if you've got all this sand, one way to survive would be to utilize it. Why not use the sand? It's so different than other kinds of soil. It's very easy to dig in. And so we have 11 different species of antlions here. Not all of them live in the soil, but a lot of them do. And some of them are pit makers like that it's easy for them to make a little pit. Other ones, they hunt just under the sand. And sometimes you can find doodles in the sand, and they're out hunting. So those are really cool to find those because those are even bigger. Pretty awesome. And we have ants out here that have venom. So there's another question. How do you, if you're going to eat ants, how do you keep yourself from being killed by the ant? This is part of why the pit is so clever and works. When an ant falls into the pit, it falls backwards. And the antlion is able to grab it and pull it under in a way that the ant can't grab on and bite and sting it because it's falling backwards. And then they can grab it and not pierce the venom sac of the ant. So that's an amazing way to survive. You're eating these incredibly dangerous creatures, these ants, and because they're falling backwards, you can grab a hold of them and then they can't hurt you, which is pretty cool. Now, some ants do escape. Some are really fast. Trap jaw ants are able to shoot themselves backwards, so they don't catch everything. The next species I want to talk about is a plant. This right here looks a lot like a Christmas tree, and in fact, I use these as Christmas trees at my house. It's called a sand pine. I'll back up here so you can see it a little better there. It's called a sand pine. Has short needles. It's pretty common here in the scrub. And the survival trait that it has that I think is amazing has to do with the cones. So check out these little cones here. You can see they're pretty small. They're very tightly packed. These cones are called serotinous cones. And what that means is that they stay closed until a fire comes through, at least for most of them. Heat opens them up. You could take this and put it in your oven and it would open this up. Here's another one down here. There we go. Let's see if I can get it on the camera. There we go. It's another one right there. Why is this an amazing survival skill? I mentioned a little while ago when we first started that we have a lot of lightning and fire down here. If you're a tree, what are you going to do about that? Because you can't dig a hole and burrow and get away from the fire. You don't have wings. You can't fly away from the fire. What this tree does is basically it accepts its fate. This tree lights up really fast with a fire. Poof, it's gone. It's dead. But it uses that opportunity to give its children a chance at life. So when this comes and burns up, that is when these pine cones open up and spread their seeds, send their seeds out there to start new life. Right after fire is a really good time to be a seed because there's not a lot of competition. The other vegetation has been burned away, so there's not a lot of competition there, and you can start growing. Now, sand pines actually sometimes they're a problem because if you don't have fire in an area, if fire's been suppressed, these take over. They just slowly take over, and you end up with a spot that's not good for, let's say Florida scrub jays. If these are taking over a scrub jay area, the scrub jays are probably going to be gone. So there's actually volunteers in Florida that cut these down, and then we see the scrub jays return. The other thing is if these take over an area, you have a whole forest of these bushy pines, when a fire comes, it is dangerous. It is too dangerous because that's a lot of fuel up burning everywhere. So speaking of fire, I'd like to introduce our guest speakers. We have Ryan and Vivian, and they're going to talk a little bit about fire and about drones. So let's see if we can get their videos on. Hey, Ryan, are you there?
Hey, Dustin.
Hey, I'm going to turn my video off and just give you the floor for the next, 5 minutes or so.
Okay, sounds good. All right, so my name is Ryan. I have a really cool job. I'm the drone pilot here at Archbold. So we use drones for a lot of different things. Mostly we use it for mapping. So this is one of our drones that we use for mapping. It's called a Phantom. You've probably seen this before. It's a pretty common drone. We wanted to show you what this looked like out in the field live, but because it's so windy, we can't go out and fly the drones. So maybe another one of these in the future, we'll be able to show you those things. So basically what we do is we just fly this drone with the camera pointed down. We take a lot of pictures, and then we put all those pictures together, and then we can make maps of where those fires went. We control the drone with our big remote control and the iPad to control the camera. It's just like a video game. You know, you got your little joysticks. It's a really fun job. I pretty much play video games for a living, right? So that's one of our drones. Another one that we have is this one. This one is called the Mavic. It doesn't really look like a drone now because this is our portable drone. Here's my water bottle. They're about the same size. So you can take this and unfold it. And then it looks a little more like a drone. So this one is really easy to put in a backpack to go out when we're doing a prescribed fire out in the scrub, so that we can watch where the fire is going, places where we need it to go, or catch it if it's going somewhere that we don't want it to go. And this one is really nice because it folds up. The controller is a lot smaller. And so between these drones, we can do all of our mapping, and we can get out to the places that we need to get to map these fires that we're doing.
All right, awesome. Thank you, Ryan. And we'll come back to Ryan in a little bit, and he'll show us a little more in a few minutes. So Ryan, you can turn your video off for now. I've got something else I want to show you that's behind me. Pop up here. Oh, hey, Viv. There we go. I got something else I want to show you that's behind me here that people ask a lot of questions about, and I want to set the record straight. What is this stuff behind me here? What is this stuff? You can type it in the chat if you know what it is. Yes, it is Spanish moss. Now here's the thing. Spanish moss is not Spanish, and it's not a moss. Other than that, it's a good name. It was called Spanish beard back in the day. It's how it got its name. The French made fun of the Spanish for having long beards, and they called it Spanish beard. And the name kind of stuck. So it's not a moss, and it's not from a different country. It's just from the southeast. And what is it then? It's actually related to pineapples. And that might seem kind of strange, but it is. It's a bromeliad like pineapples. It doesn't get a big fruit that you can eat on it, unfortunately. It's also called an air plant. An air plant is a plant that doesn't have roots, and it just grows on something else, like this oak tree behind me. It's not a parasite. But one of the things people always wonder about is, are these killing the trees? No, they're not parasites on the trees. Now, if you do have a lot of them on a tree, they could get heavy. If you've got a dead branch, then maybe a bunch of this soaking wet in the rain would help the branch to fall off. But they're not harming the tree. So, not Spanish, it's not a moss, it's an air plant related to pineapple. How does that work, though? How does it survive? If it doesn't have roots, how is it getting water? How is it getting nutrients? Well, we're going to take a look here. I'll put it under the camera, and we can take a closer look at it. And what I want you to do is look for little scales. There's always little scales on it. See those little scales there? It's a special kind of plant because those little scales, they can actually absorb the nutrients and absorb water. Now, right now, they're all gray. But I'm going to try something here in a second. I brought some water out with me. Oh, sorry, let me switch back. I brought some water out with me. Just a little bit of water here. And we're gonna pretend like it's raining. So I've got my Spanish moss. I can show you this. Turn my camera down there. Here's my water. I've got the Spanish moss. And I'm gonna stick it down in the water there. Mix it around a little bit. And you might start to see something going on with the Spanish moss. That the color of the Spanish moss is changing. I'll pull it out here in a second so you can really see what I'm talking about. But it's now changing green. And when we think about plants and how they survive, we normally think about the fact that they're green because there's chlorophyll in there helping them to photosynthesize. So they're taking nutrients. Most plants are taking nutrients from the soil. They're taking carbon dioxide from the air, and they're taking water, mixing it together, and providing food for themselves. But if you're a Spanish moss and you don't have roots, you have really got to worry that you are going to lose all your water. So what they normally do during the day is hold those scales closed and try to hold all their water in. Well, let's take a look. Flip this around again. Let's see them now looking green. And now these wet parts that are green, what you're seeing is that they've actually opened themselves up. The scales have opened up a little bit in order to grab on and soak up all that water. And they won't stay green for long. They'll close back up. They're going to soak up all that water, and they're exposing their chlorophyll to the sunlight, so they're photosynthesizing a little bit right now, and they'll hold on to it. They actually have this other really crazy thing that they do, which is we think of plants doing all of their activities at night, but during the day, but they'll actually wait till nighttime where they won't lose as much water, and then that's when they'll also open up again. Okay, I want to go back to our drone people, to Vivian and Ryan. They've got some more stuff they want to show us, and then we'll wrap up and do some questions and answers. So if you've got questions about any of the things we've looked at, please just type that in the chat, and we will get to those questions in just another 5 minutes or so. All right, Ryan and Viv.
So I wanted to show you a quick video of some of the drone footage that we collect while we are out in the field. So Ryan was talking about taking one of the drones out with us and bringing it on a prescribed fire so we can monitor what's going on. And so we can see how the fire is moving across the landscape. We can monitor to make sure the fire is staying within the boundaries that we want it to. Let me share my screen here quickly and I can get this video going. All right, so here you can see the drone launching up from the ground in a prescribed fire. This is up on Red Hill, and this is one of the units that we're burning. You can see the outer boundary of the fire. You can see the wind is blowing in this direction that my mouse is moving in. And so we made this black area to protect it so that it doesn't spot over into another unit. It's a really, really useful management tool that we have to keep track of fires while we're on a fire, watching what's happening. We can look around. You can see some lakes in the background. This is actually Lake Placid, the big one, and Lake Annie is just in front of that, a much smaller one over there. And you can even see 27 running over there since we're up on Red Hill from where we are. So it's a really, really awesome tool to have to use while we're out in the field and monitor. And you'll see here in a minute, I start looking around with the drone, trying to see, to make sure that there's not any fire in any places that we didn't intentionally put it. And you can see there's some pretty big flames in there running across. And so we light the fire strategically so that we can have this lower intensity fire, creating the safe space before the big flames. Here, I spotted a little bit of smoke over there in the background. And I was like, oh, what is that? Let me go and see with the drone. And what I noticed is that it was this farmers have it burning a burn pile, you know, so it wasn't an impact of us. So then I go back to keep monitoring the fire. And looking around in other directions to make sure there's no impacts. And then once the fire is done, what we end up doing is mapping the fire. And so we will bring the drone up and we will map over this whole unit in a grid pattern and stitch the image together so that we can actually see the extent of the fire and the intensity, which you can tell by how charred the ground is. It's really amazing to be able to get this aerial view of something that you're doing. And normally you're on the ground walking along here, lighting things, and you don't really know, you can't see from this perspective what's happening. You would have people on all sides of this fire monitoring, making sure as well from the ground, looking out to make sure nothing is getting out of our control. But this is just an extra tool to be able to do that. So I will stop sharing that. And I believe that we have a couple of slides where you can see what it looks like afterwards. So this is that same unit after the fire. You can see the whole unit didn't burn, and that is that area on the left of the screen didn't burn, and that is because it's actually started raining that afternoon. And so that put that fire out very, very quickly. Otherwise, we would have tried to get that whole area that's shown in black. But then we can see the extent, and you can see some areas in there that are still green that didn't burn. And so the next step is to try and map the fire. And so if you go to the next slide, you can then see we've got different intensity mappings on there. So everything that is showing up in red is saying it was a high intensity. It was a really, really hot area, hot fire. And some of those yellow areas were where there was more low intensity. And you can see that bright green dot in the middle. That was that circle, that treed area that the fire just didn't get to. Maybe it was too dense. Maybe it started raining before it got there. There's a variety of reasons. But mapping the spatial pattern of the fires is super important for all of the research that we do at Archbold.
Thank you, thank you. That stuff is just so cool. But it was so windy outside that I don't know how well you were hearing me before. So I booked it back as fast as I could. So I'm back at the Learning Center now. So I'm sorry about the wind. Thank you all for sticking with us. We're going to go to our question and answer time. I don't know what schedule everybody's on, but if you've got to get back to class, then it was wonderful to see you. We'll take another 10, 15 minutes. And remember, we are every Tuesday morning doing some version of this and having different guests on and seeing what kinds of stuff are out there. So hopefully we'll see you later. Hasta pronto, amigos. And with that, let's go to some questions. Margaret, do we have anything in our Q&A?
We do. The Riley family is wondering for Vivian and Ryan, when you take drone footage for mapping, do you have to be pointing the camera straight down over the area, or can you still map when you're filming at an angle?
So it really depends on what you are doing with the drone. If you're trying to map a fire, like we were showing in those slides, where you get that, really nice, crisp picture, like you were looking at Google Maps or something like that, then you have to have the camera pointed straight down while you are, and it takes pictures in a gridded pattern along with a certain amount of overlap. And then there's software that we can use to stitch that together into one picture. If you are monitoring the fire like the video was, we're just moving the angle of the camera at all, while we're flying around and getting live video. So it really, really just depends. Some of the more recent things that we've been trying to do are map in 3D. So try and get the shape of a tree or a shrub or something like that. And that still has a gridded pattern that we are flying in, but you might have the angle of the camera slightly off from straight down so that you can kind of get at the shape and what underneath, what it looks like underneath the very top of the canopy of the trees.
And also I see Karen is asking, how do you control the fire if it gets out of the boundaries?
If it gets out of the boundaries, we are all hands on deck, putting it out as fast as possible. So we've got a lot of fire trucks up there with a lot of water. We're all equipped and ready to go. That's why monitoring is so important. People on the ground, having us up in the air. As soon as you see anything like that, we would get a truck with water and a few people over there spraying water on it, using a flapper to smother the fire around the edges and getting it out as soon as possible. That is why it's such an important part of prescribed fire.
Awesome. Okay, and there are a few questions for Dustin as well, but I guess this could go to either of y'all, but what prevents sand pine seeds from burning when the fire hits the sand pine and opens the cones?
Well, it's a good question. I don't know how many of them do get burned up. My guess is that some of them probably do, but the whole purpose of the pine cone is to protect those seeds inside there. So I don't know how long it takes after they slowly open from the fire for the seeds to start falling out. But I don't think it's like fire comes and they just all shoot out while the fire is going by. I don't know, Vivian, do you have any more details on that?
Yeah, I think it also depends on how fast the fire is moving across the unit. If it's a very quick fire, it's not going to really burn up those pine cones too much. But if it's a slow moving fire, they would probably get a little bit more charred. And you certainly see charred pine cones all over the place. But I think that it just opens the cone. And then afterwards, when it's rolling around and the wind is blowing, maybe that's when the seeds would fall out. But I don't know exactly the answer, but that's my best guess.
One thing that some researchers have looked at is that the relationship to fire, because some areas where that pine lives has more fire than others. And so they've been able to show that those areas that don't have as much fire, more of their seeds will open without a fire. They don't always need a fire. And then even down here, not every single cone will wait for a fire. So I think that's one of those interesting things of actually seeing the natural processes have an effect on a species. Because they're trying to, whatever works in that area is going to be what gets carried on to the future generations.
Nice. Arena from Facebook is asking, what happens to animals during the fire? And do you ever find any injured animals?
Well, Vivian, you can take that one.
Sure. Yeah. We will see animals run out of the burn units. They can smell and sense when the fires are coming. So sometimes you'll see a bunny or a deer get out of there as soon as possible. I think that they, those mammals can move out of the way quickly. They can sense what's happening. Some of the other animals will actually use the gopher tortoise burrows. And so the gopher tortoise burrows are deep enough that they are protected from the fire. And so a lot of snakes or, other types of species would end up going down into the burrows while the fire passes over, and then they'll come back out afterwards as well. So it kind of acts as a refuge. I don't know if you want to add to that, Dustin.
Well, we were talking a lot about sand today, and sand is a great insulator against fire. So if you can get below ground, you're okay. And a lot of the plants here, well, the question was about animals, but with the plants all have different adaptations too. So a lot of them, the above ground growth gets all burnt back and looks like it's dead, but the plant's still alive. It's just the part under the sand is still alive and pops right back out again.
The other thing that animals might use is water. There's a lot of seasonal ponds out in the scrub. That video I was showing didn't really have any water in it with the habitat that it was, but many of those burn units have big seasonal ponds in them. And so a lot of the wildlife will move into those wet areas and places they know they can be safe.
So some of the animals actually are benefited by fire in a direct way because a lot of insects die. So some birds love fire, and they'll come right in after a fire and looking for all the grasshoppers and things. And there's actually a bird, I'm trying to remember, I think it's in Australia, that has been documented to actually spread fire. So there'll be a fire and it'll go down and pick up a branch that's burning, fly with it and drop it in other spots to keep the fire going and spreading the fire so it can eat those insects. For those that are on the Zoom, we send an email tomorrow or the day after. I'll find that bird, I'll find that story, and I'll put it in the email for you.
The Riley family has a follow-up question to that, which is, are there enough gopher tortoise burrows? And in areas where there might not be enough burrows, do people make artificial burrows so animals can use that?
Oh, no one's ever asked me that. I've never heard of people making artificial burrows for that purpose. And at Archbold, we do, depending on the species, we will do some maintenance of the landscape to benefit them. For instance, for red-cockaded woodpeckers, we will go and actually go up into a longleaf pine tree and cut a hole in it and put a fake bird cavity in there, like a birdhouse, because, well, for various reasons, but we will do that. When it comes to gopher tortoises, we don't do fake ones. The only time I've ever heard of any of the researchers here making a fake one was for a project where they had made fake little gopher tortoises, and they used a 3D printer. It was super cool. They had a fake little burrow. They'd set the little fake baby there and put a camera on it so they could watch all the other animals come by and react to it, and see the raccoons and bears and stuff try to, gnaw the head off of the baby gopher tortoises to learn what's it like to be a gopher tortoise. But I think the thing is that, nature knows what it's doing. It's adapted for it. And fire has been such a big part of Florida for, so many, hundreds of thousands or maybe millions of years, that if it's a species that has been here for thousands of years, it survives in fire. Even if some of individuals die, that population overall survives, or they wouldn't be here.
All right, Denise asks, are lion ants only found in Florida?
No, antlions are, I don't know the full distribution, if they're just in North America or not. If somebody knows, they could type it in the chat, but they're definitely not just in Florida. Like I said, we have 11 species here. They're not all in the sand. Some of them live on trees. And I don't know how many species are in the world, but it'd be interesting to look that up.
And also in antlions, Karen asked, do they locate their pits in shady spots only or also in sunny spots? And then I think she's wondering if they're more active in the sun or maybe it gets too hot.
Well, I don't know that the sun is the factor. It's being out of the rain, I think, is the main factor. They are very picky about the sand that they use. And this is not going from reading research, but from catching many antlions. They love the spots that are protected from the rain. So where we were just looking at them, you'd find that was next to that pine tree. You can also find them next to the sides of buildings with overhangs. So they like loose, dry sand that they can easily work with. And it's very hard if it rains. It's very hard to find your antlions, just like it's hard on a really cold day to find antlions. So I'm not sure if the shade is just because, that's an area that's protected or not. But sometimes you also see the ones that roam around. They're right in the middle of those paths, and those are very bright. There's no shade at all in those spots.
Cool. And we have another drone question, which is, how do you manage drone batteries? Do you have to keep bringing them back and putting in new batteries?
So we have several different batteries for both of our drones. We have 5 or 6. They look like this. They just charge up on a charger, and we just charge all of them that we have and bring them out with us whenever we go fly, so that we can fly everything that we need to. They usually last about 25 minutes, give or take. So.
Awesome. I'm not seeing, oh, I think there is a new question. 1 second. Oh, can drones fly quietly?
I'm sure that they can. It's not really something you can adjust. It's just different drones sound differently. Ours are kind of loud, but I'm sure that it varies based on the different kinds of drones that you can get.
They do make different propellers that you can put on the drones. The drones that we have are quadcopters, so they have the 4 spinning blades. They're supposed to be quiet blades, but it's really, they're still pretty loud. It's interesting because there have been some studies done where looking at how wildlife responds to drones, and you can tell when we're out flying, some wildlife doesn't care at all about it, and some wildlife is like, what is that? It sounds like a swarm of bees, please get away from me. So it's really interesting. But once you get it up at the height that we're flying at, you can barely hear it from the ground. It's only when you're launching in those lower levels that you can hear it.
And I know that I think it was a year ago or so, we did a little project with Cara to see if drones could be used to help monitor them, and they were too loud. They weren't able to use them.
Birds are always typically pretty curious about what is that other thing that's flying around that they've never seen before. You know, the scrub jays squawk at it. So I could see that, you know, it's your territory of flying, the air flying around, and now there's this unknown object in there. So I can totally understand that.
Oh yeah, I guess not just the sound, it's also a big blob.
Exactly. And there are different kinds of drones. Ours are the quadcopters. I think that they make fixed wing drones as well, which don't have those spinning blades that are more a flat, look like a mini airplane. I think those ones aren't quite as loud, but they are, you know, have a variety of different purposes than the ones that we have.
Are drones used during nesting season for birds? Or is there like regulation with that?
I don't know of any regulation around that. We're not really flying the drone for the birds, anything for the birds specifically. We're mostly flying around habitat questions, and so mapping fires or looking at vegetation structure or things like that. And I don't think that there's known impacts for the small amount of sound that they would hear from the drone. We're not doing any type of work that is directly impacting any of these listed species, so we don't have to worry about that.
Alrighty, and this is my personal question, but when it comes to monitoring controlled burns, is there a risk with flying around so much smoke? Does there need to be a certain amount of elevation that you have to reach?
You know, we have been learning that as we go. The drones actually have an obstacle avoidance system on them so that they don't fly into things like trees or buildings. And the obstacle it detects the smoke as an obstacle, so it will not let you get too close to the smoke because it sees it as something that it should not fly into. So it starts beeping at you, and it physically will not get too close to that smoke. The other things that are concerns with that are going to be the temperature. You know, the smoke is obviously from fire, so it's hot, and the drone is made mostly out of plastic. So we try and stay out of the range of the smoke. We're trying to see where the smoke is going, and if you're in that plume of smoke, you're not seeing where anything is going. So we're looking at it from the outskirts.
I just wanted to add to Karen's, I saw she had a follow-up on there about disturbing birds. So if it's a protected species, it doesn't matter if it's a drone or whatever you're doing, you can't harass the birds. So, you know, Vivian's saying that there aren't yet rules that are specific to drones on that. But if you had a bald eagle nest and you're flying a drone and it's bothering them, that's illegal to do. And as a photographer, I've read terrible stories of people in Florida paying to get brought out to rookeries for birds and wanting to photograph beautiful birds, and they go over and then all the birds take off. That is bad. So if anybody on here is a wildlife photographer or an amateur wildlife photographer, part of conservation and wanting to protect those animals that you're photographing because you think they're beautiful or valuable, worthy to photograph, is thinking about the ethics of photography, and drones are part of that too. So whether you're on foot getting too close to take a picture or using a drone, you have to be aware of the unintended consequences.
Okay, one last question. I see that the Riley family wants to know, how did you map and observe the fires before drones? They seem very useful.
They are indeed very, very useful. So we always have been monitoring fires as they're going on from the ground. And so there's very strict protocols about how you're supposed to monitor a prescribed fire from the ground. And if you have people surrounding the burn unit looking out in all those directions, you can see what's happening and look out for markers like smoke or embers flying in the wind to monitor from the ground. Excuse me. From the air, we've always been mapping fires. We've been mapping fires at Archbold since the mid-70s. Historically, what we used to do is go up in a little two-seater plane. And I got to do it one time before we started our drone program, and we would bring a camera up in us and hold the camera slightly over the edge and snap a bunch of photos of that fire. And we would fly that plane in a grid pattern, just like the drone does, and try and get enough photos to be able to stitch that together. The quality wasn't great, but it was enough for us to map the extent of the fire and see areas that didn't burn or areas that burned, at very different intensities. So we've been doing it for a really long time, but now the quality of our data is substantially improved by having the drones. And the other thing is that we can get out the day after a fire, so we can see immediate changes or immediate what the effect of the fire was on the landscape. When we were doing it in a plane, it might be a week or two that would go by after a fire before we could get up there, sometimes even longer. At that point, stuff starts to grow back, and so you're not getting that good quality data as much as we are now. So now we're struggling with how much data is too much data, or how do we balance this long-term data set of having not great quality but good quality with what we have now, which is great quality data.
Okay, I lied when I said one last question, because now it's one last question. If you get a lightning strike fire happening, would you want to try to directly take advantage of it, or is that not possible?
No, we would not. We would try and put that out immediately. You have to get a prescription written to be able to do a prescribed fire and approved by forestry. And they're looking at a variety of different conditions, what the surrounding landscape is, what the wind direction is. If the wind is going to be blowing the smoke onto a road, they wouldn't approve a fire for that day. If you're going to impact a housing development, they wouldn't approve a fire for that day. Also, just other, dispersion aspects. There's so many things that go into whether or not a fire gets approved to be done as a controlled burn or not. And so anytime there's a wildfire, however it starts, the goal is to get it put out as fast as possible.
Awesome. I think that is all the questions that I see. Dustin, do you have anything to add?
Thank you. No, thank you so much, Ryan and Vivian, and all those who stuck with us. I'm afraid to rewatch this because of all the wind sound. But for those who stuck it out, thank you so much. Have a wonderful week, and we'll be back next Tuesday.